Its global production has doubled about every decade. According to estimates, over 380 million tons of plastic is produced every year. It's no surprise then that the plastic industry is valued at over $600 billion. So how is it made? Crude oil, the primary raw material for plastic, is extracted through a process called drilling. It involves drilling a well bore into the Earth's crust to reach underground reservoirs that contain oil. The drilling process typically uses a drilling rig, which is equipped with specialized equipment to penetrate the ground. Once the wellbore reaches the reservoir, the pressure within the reservoir forces the crude oil to flow up to the wellbore. This initial flow is often aided by the natural reservoir pressure. But as the pressure decreases over time, other techniques like pumping or injecting gases and fluids may be used to enhance oil recovery. Once extracted, crude oil undergoes refining by heating it in a furnace to about 752 degrees Fahrenheit or 400 degrees Celsius. Vapors from the oil move into a fractioning column, a tall tower containing a series of chambers. The chambers are warmer at the bottom of the tower and cooler at the top. The various substances that make up petroleum rise through the chambers as gases until they reach the temperature at which they become liquids. Since each substance has a different boiling point, it liquefies in different chambers and can be separated and collected. Ethane and propane, the building blocks of plastic, have low boiling points and are collected as gases from the top of the tower. Ethane and propane fractions, now separated from the crude oil, are subjected to a process called cracking. Cracking breaks down the larger hydrocarbon molecules in these fractions into smaller, more valuable molecules like ethylene and propylene. These smaller molecules are the monomers used in plastic production. The cracked ethylene and propylene monomers are then collected and prepared for the polymerization process. Polymerization. Polymerization is the core process in plastic manufacturing. There are two main methods. Addition polymerization. Monomers like ethylene and propylene undergo addition polymerization. Catalysts and initiators are used to break the double bonds in the monomers and create polymer chains. Polyethylene, polypropylene, and polyvinyl chloride, PVC, are produced using this method. Condensation polymerization. Some plastics are formed through condensation polymerization, where two different monomers react, releasing a byproduct like water. Nylon and polyester are examples of plastics formed this way. After polymerization, the resulting plastic can be converted into standardized plastic pellets, also known as nurdles. This process involves extruding the plastic into strands, cutting those strands into pellets, and cooling and drying them to maintain their quality. The nurdles are then packaged and transported to plastic manufacturers who use them as raw material for various plastic production processes. Once the plastic pellets are received, they are melted and shaped into various forms using techniques like injection molding, extrusion, and blow molding. These processes determine the final product's size, shape, and properties. After shaping, the plastic is cooled and solidified to retain its intended form and properties. Plastic properties can be enhanced by incorporating additives during or after polymerization. These additives impart color, UV resistance, flame retardancy, flexibility, and other desired characteristics. In addition to primary plastic production, nurdles can also be used in the recycling process. Recycled plastic materials can be pelletized to create recycled plastic pellets, which are then used to manufacture new plastic products with recycled content. Nurdles can spill at every stage of the plastic production process, from production sites, during transportation, and in the manufacturing stages. Factory spills and spills during transit are a result of limited awareness, careless handling, insecure storage, and inappropriate equipment. When nurdles spill onto the ground, wind and rain can wash them down storm drains or into waterways, from where they ultimately end up in the ocean. To prevent nurdle spillage and uphold responsible plastic manufacturing, a range of quality control procedures should be implemented. This involves establishing good manufacturing practices, GMP, tailored to plastic pellet production, utilizing proper handling and storage guidelines, ensuring robust pellet packaging, conducting regular quality assurance checks and providing thorough employee training on spill prevention and response. Thinking of application, here's how plastic Coca-Cola bottles are made. Mirrors, as we know them today, were invented by the Venetians, but the process of how they were made was a secret for nearly a century. It was at the end of the 16th century that the secret was leaked through industrial espionage and the global mirror market was born. Now, the industry generates over $100 billion every year. But how are they made? The very first hurdle is procuring quality glass. Although it's the main component of mirrors, glass is a very poor reflector by itself, reflecting only 4% of the light which strikes it. However, it does possess the property of uniformity, which makes it a top contender for an effective base in the mirror market. It's also easier to mold into various shapes for specialty mirrors. Given these qualities, it's an industry favorite. In terms of production, glass sheets are primarily made from silica, which can be refined or mined from sand. There's also synthetic glass, which is made from synthetic fused silica. After the glass arrives at the factory, it's transported on a conveyor belt to the washing station. Their sprayers blast the glass with water and cerium oxide, a powder obtained from various minerals, the most common being monazite. Rotating brushes scrub and polish both the top and bottom surfaces, thereby removing oils and any other impurities. The whole process takes about a minute and a half, after which the glass sheet is ready to be coated with a reflective material. Before that can happen, the glass is sprayed with piping hot demineralized water. This is because the minerals in ordinary tap water may damage the metals that are applied next. The first metal to be applied is liquefied tin, which goes on to the back of the glass. It allows the primary reflective metal, silver, to adhere to the glass, which doesn't otherwise. The applied silver is also in liquid form and is mixed with a chemical activator. Within seconds of being applied, the silver begins reacting with the tin and hardens the surface of the glass sheet. As it does, you begin to see a reflection. The process is called silvering and was actually invented by the German chemist Justus von Liebig. Before the discovery of silvering, lead and mercury were used as reflective materials. These metals were quickly abandoned in favor of silver, which both had a higher reflectance and was not toxic to humans. Although these days, modern mirrors use aluminum rather than silver. Aluminum actually has the highest level of reflection out of any other metal in the ultraviolet and infrared spectral ranges. It's also more readily available, which is why it's no wonder that it has sidelined silver in the glass market. After the silver has been applied, the glass sheet is run through a series of sprayers that rinse off the excess silver, which gets recycled back into the system. To protect the silver and seal it to the glass, the factory coats the glass sheet with 2 layers of paint. However, these coats aren't enough to protect the silver by themselves. For some extra protection, the factories first coat the glass with a layer of copper. Afterwards, sprayers rinse off the excess copper and the glass panel is run through a dryer, which drives up the temperature to 71 degrees Celsius. This evaporates any moisture on the surface of the glass within 75 seconds. Now the panel passes copper side up through a curtain coater. The machine is so named because it runs a continuous curtain of paint across the conveyor belt. After the first coat is applied, the glass runs through a dryer at 99 degrees Celsius. When the paint is cured, it's time for another coat. The second coat is a different color than the first one, just so it's easier to differentiate between the coats. Once the second coat is done, the panel of glass is run through another dryer. This time, the curing period is twice as long and at a higher temperature, 118 degrees Celsius. The glass panel is now given an acid wash to remove any unwanted metal residue and is then handed over to a team responsible for quality control. These people ensure there's no fault with the surface of the glass. If they find such a fault, like a bubble on the surface, instead of wasting the entire glass, they simply cut that portion out. Once the mirror is complete, it's cut into the desired shape depending on the type requested by the client. Cutting is usually done through a saw with diamond dust embedded in the tips. This is because diamond, being the strongest material known on Earth, can cut through glass like a hot knife cuts through butter. The mirror is now ready to be shipped off to locations around the Earth. Let us know in the comments what else we should do a video about. And check this video right here.